Hello, everyone. Welcome to another one of our deep dives, today about telemetry in Foreman. Those of you who've watched our latest community demo already got a preview of this. Lukáš will tell us more today. For those of you on YouTube, please notice the quality of your video. The default is not great for screen sharing, so please up that. For any questions, we're on Freenode, the Foreman, on Twitter, or on the YouTube live chat. Lukáš. To you.
Yeah, can I start? Hey. Yep. So hello everyone again. And in this deep dive, we'll have an hour about Foreman Rails application instrumentation implementation. That's a nice topic I made up. Basically, it's a new code that has been merged in nightly in develop branch and will appear in 1.18 stable release, and it adds capability of exporting some interesting internal data from Rails application. In the future, we would like to maybe extend this to other components, things like Dynflow, Smart Proxy would be also interesting. And yeah, I'm Lukáš, and you can reach me at LZAP on Twitter. And let's go straight. Today we'll do. I'll show a configuration of Rails, how to actually enable telemetry. Then we'll take a look on how to set things with Prometheus. We'll spend a minute on how set things up on PCP. Then I'll talk about a little bit about configurations and histograms. And then we'll have a short block of about how you can add your own metrics to core or to your plugin. So basically a description of the API, which is fairly simple. And then, well, I'll show something with Prometheus I've set up on my nightly build, or nightly production instance, rather. And then we'll have a Q&A session. Although there's a dedicated Q&A session here, please go ahead and ask on the Q&A button and in the YouTube, or also on the Foreman IRC channel. So yeah, if you install nightly these days, although we have some a little bit of dependency issues at the moment, these are being worked on as we speak. I installed basically a stable version and then applied the patch to show you the telemetry patch to the feature. So maybe next week, if you install nightly, you can grab the settings.yaml.example, and you'll see a new block there. It's called telemetry. Then it has a few options there, and you can. It's commented, but for the sake of readability, I remove those. And basically, you set two things. You set a prefix, which is just a prefix string that is prepended to all the metrics. We'll see that later. By defaults to Foreman or _Rails or FM Rails. And then you can enable Prometheus endpoint or StatsT endpoint, or both. Doesn't matter. You can enable both for if you're testing or trying that. It does work. There's no issues with that. And the idea behind telemetry is that we assume that lots of you, Foreman users and satellite customers, you have some monitoring already in place, and we would like to, as we see our community growing, as we see more and more deployments. We've seen there was a presentation 5 years ago scaling Foreman up to 100K hosts. So yeah, as our community grows, we see more of these, and also we also see more and more performance issues and bugzillas opened, and to be able to work with those performance bottlenecks, we need to see numbers, really hard numbers, because you can't build your patches performance improvements on the green field. So Rails already provides some interesting internal or telemetry data. It was pretty natural to hook into that and export that to existing monitoring solutions. And I was working for maybe a year. Was my pet's evening project to create integrations with few monitoring solutions. I have experiences with collectD, Nagios, and PCP, and now a little bit of Prometheus. And I've decided to make the telemetry API in a way that it's a common API, a very simple common API that works with I would say the most trending technology these days in the monitoring field, that is Prometheus, and also it's something pretty old, very simple, that assures that you can integrate the telemetry data with pretty much anything, and that's StatsT protocol. It's very simple. Both technologies has advantages, disadvantages, but what's interesting is Prometheus is pull-based and StatsT is push-based. So this is a little bit of a big difference, which is great because we cover basically both scenarios there. So if you're maybe in containers, you prefer push-based, or in VMs, you prefer pull-based there, or there are you have two options basically. So as you can see, because Prometheus is pull-based, you don't basically set anything. You just enable it, and it will basically create a middleware. You need to, of course, restart Rails, restart Passenger, and there will be new endpoint at /metrics, where you can start gathering and Prometheus data, the metrics, the numbers. StatsT works a different way. Basically, you enable that, and you need to provide a host and port. It's a very easy protocol that sets a UDP package to particular host and port with all the statistics there, so counters, gauges, and duration measurements. Right away, it doesn't do any aggregation at all. It just leaves the application as soon as possible, and you aggregate the data later. So you need obviously you need to set a host name. You don't use DNS here because you don't want to do a DNS resolution on each of these measurements. A typical Rails request would send, I don't know, dozen, maybe 2 dozens of measurements. And always use localhost, although it's possible to send this across network. The typical setup of StatsT is that you have a local aggregator running, and the port is pretty much de facto standard. Keep in mind this is UDP. Let me just quickly, okay. So once I've enabled Prometheus, the next step is we'll now talk a little bit about both ways. All right, so starting with Prometheus, you want to start Prometheus. Obviously, you want to give it some configuration. Prometheus is written in Go. It's just one binary you can grab. It's in Fedora. I don't think it's in RHEL or EPEL. I don't know. I haven't checked. And basically, you give it, all you need to do is tell it where it needs to scrape the data. So in our case, it's localhost, HTTP. I think it should be 80. I have a mistake there. It's 80. I'm not sure if HTTPS would work, but I'm not sure if Prometheus would error out on certificates, because you need to add a server certificate to the system or Prometheus. So I think the correct number here is 80. And that's pretty much it. You give it a job name. That's just a descriptive name of a scrape endpoint, and that's it. If you're running Prometheus, it's a good idea to also grab some information from the OS. That's CPU, memory, I/O, stuff like that. There is another program, another binary you can download from Prometheus.io site that's called node_exporter. If you run that, that doesn't need any configuration at all. By default, it's same default. It will give you that as well. And you want also to grab Passenger Exporter. That's a third-party exporter. So although there's a link from Prometheus.io, I think, a website, it's in GitHub. And you want to start that as well. Then you obviously need to add two new endpoints here. called node and passenger. These are the default ports if you don't specify. And this will give you enough information so you can correlate those with your telemetry data. Now it looks great. It's easy to configure, but there is one snag. It's just it doesn't work because in the Ruby world, we have web servers which spawns multiple processes. Usually, that's how it's done today. Maybe Ruby 3 will change that with the new concept of concurrency, but until then, we have to work with that. It looks to me that Prometheus is kind of a new stack thing that assumes that you have a microservices, mostly written in Go, one process, one maybe container, multiple containers, and so that works great. But the problem with Prometheus client library is that it doesn't doesn't aggregate the data. It's just per process. And the thing is, if you hit the /metrics endpoint, and you have a multi-process stack, which is obviously passenger in our case, and production install, or even Nginx if you're running the Nginx or any other web server, you're gathering randomly. There's round robin load balance or something, and you're gathering wrong numbers. Actually, for example, counters must be monotonically increasing numbers, and if you do a round robin, you're getting basically random numbers that won't work. So why we actually integrated with Prometheus? Well, we think that there is an issue reported from 2015. There's a long discussion. There are several workarounds, several experimental branches. So it's being worked on. There's also a nicer workaround that was implemented by guys from Discourse, but it's essentially a HTTP JSON endpoint that grabs the data and aggregates the data. It's useful when you're deploying clouds, like in pure Ruby environments and stuff like that. But there's a nice solution that works for us, and that's StatsT Exporter, which is a official exporter. You can download it from Prometheus.io site. And what it does is basically it listens on a UDP packet and it creates the /metrics endpoint, so you can Prometheus actually can grab those numbers, and it also aggregates the data, which is important as well, because that's just fire and forget. So you grab that and you run that. Before you run that, you need to have a mapping. Actually, you don't need to have any mapping. It will work out of the box. But if you have mapping, your output is much more nicer, because as we'll go through the labels and how this works in Prometheus, we'll find that it's very nice to have those labels set properly. So with Foreman, there is a new rake task called Telemetry Prometheus StatsT, and you give it an output file, and it will create a mapping file, which is a YAML. Looks like, I hope that's readable, but basically it's just YAML that says everything that is named HTTP request DB duration .something maps to this, the very same name actually in Prometheus, and the first and second are labels called action and controller. It also maps the help, or the descriptive helps text or string, which is also nice because that bubbles up to your graphs. And also you can configure buckets. A lot more about buckets and histograms later, but this way you can easily tune your buckets if you want to have a nicer percentiles. So you create this mapping. You just generate the mapping once after you upgrade your Foreman's instance, and then you run the StatsT Exporter. And then you basically change the first job name from the first endpoint from, it was set to Foreman and directly to the endpoint running on Foreman via passenger. Now it changes to localhost 9102. That's the default port. That's the StatsT Exporter exports data, and then under, if you go there and slash metrics, you'd find all the aggregated data from StatsT. And the ultimate URL you want to hit when you want to connect to Prometheus is your host name 9090. So here's the it's a very basic graphical interface you can work with. You can do queries. We'll talk about this a little bit later. But the design behind Prometheus is this is a time series database. I think it only stores some days or hours of data, and then it's lost. So you want to maybe export data somewhere else. We won't talk about this, and I'm not a Prometheus expert at all. So we'll just touch and see some graphs at the end of the video. So this is how you basically configure telemetry data to show up in Prometheus. So in Nightly, what you have is this. There are new dependencies: Prometheus client, StatsT client, which are now shipped in our repositories. These are Ruby gems, and there's new configuration, and it's a little bit of code. Telemetry Core API. I'll show you later. And there are a couple of measurements spread around the applications. I'll show you what we are currently measuring or what metrics are available today. A little bit about PCP, which is a nice monitoring utility, which is included in Fedora, CentOS, RHEL, and derivates, also of course Debian and Ubuntu. It's a nice tool, nice monitoring tool, because it's a little bit basically where Prometheus excels, which is on-site, monitoring. The PCP is very good for off-site investigations. When you have deployment somewhere else you can't reach, maybe our community user needs help, and we'd like to see numbers or internal data from Foreman, maybe correlated that with the CPU or memories graphs. PCP is very good in that. You install that, you run pmcd daemon, pmlogger daemon, and will basically every day will create in varlog PCP somewhere. I'm not sure about the path. It'll be a 5 to 10 megabytes file every day, and you can grab that, send it over to mail, or attach that to issue Redmine, Bugzilla, and we can investigate it. Load up. There's a package called PCP System Tools, which contains like 3 dozens of utilities you can use, and you can aggregate the data. You can see that on graphs. You can do statistics. You can even watch the things like top or IOStat, like as you were in front of the console, in front of the server terminal yesterday or a week before. That's super cool. So I like that monitoring system as well. The way you integrate that is pretty straightforward on Fedora. You basically install PCP, enable that. There's a couple of commands, and then you also install agent. These are called PMDAs, PCP Monitoring Daemon Agent. Not sure about the name. One of these is called Prometheus. So you basically enable that. You go into directory and you create a config file, basically, which is a URL. That's the URL where the metrics are being. There is a wrong port here. I think it should be if you want to use this with the UDP, of course, with the UDP. So it's 9102. So here you should have 9102 localhost 9102. Let me just quickly fix this just to make sure. 9102, and we also had here localhost. It should be localhost 80, port 80, right? All right, so that's okay. that's it. There's an install script. That's how you actually enable or configure PMDAs, and it will grab the data from Rails. Of course, PCP itself monitors CPU, memory, stuff like that. It also can monitor, particular processes in more details. So we can say, monitor all the Java apps. I want to see a lot more, maybe memory, RSS and stuff like that, or Cupid or stuff like that. I'm working on an article that will hopefully be available in two sprints later, as I have more different priorities right now, but there will be article how to configure that. And also I'm working on an article for Prometheus. So basically all the slides there we saw will be available as either article or part of our documentation. I'm not sure yet, but this is the artifact I'm going to provide. On Rails 7 though, the Prometheus is not available, unfortunately. Hopefully it will be. I don't know, and because the history shows that PCP package is being rebased from time to time. So in 6.4, I think there was a new rebase of a new version. But if you want to use that today, you can either grab the PMDA and can compile it. It's actually written in Python, so you don't actually need to compile. You just grab the PCP PMDA Prometheus from Git, put it into varly PCP PMDAs, and start it. So it's really no big deal. Or there's another approach you can take. I wrote PCP provides an MMV API, which stands for it's memory mapped API that's used for high performance telemetry for high HPC applications, or for, it's memory mapped. So basically you write a counter, increase counter in memory, and that's it. So it's the fastest possible, maybe perhaps one of the fastest possible monitoring. It's very tight, so you need to compile the MMV library into your application. And I made a small team on PCP MMV StatsT, which does what you'd expect. It listens on StatsT port, and it using MMV it writes the data there, so it's available. And it also aggregates the durations, or it has a support for histograms as well. You can maybe try that. It's just tiny little daemon I wrote a year ago, I think. It hasn't been tested on real world scenarios, so please keep that in mind if you want to try it. I'd be very happy to see the feedback or hear the feedback. Maybe it's better way, maybe it's better than Prometheus. I don't really know, so let me know if you're interested. Maybe you want to use a different StatsT aggregator like StatsSite, which is a very nice daemon written in C, super fast, that's able to aggregate data and export using basically a script to a different monitoring systems. So maybe you have a better solution than these two. Let me know, please. Okay, so end of the section, how to configure basically telemetry data with your monitoring solution. We touched Prometheus, we touched PCP, but there are others, of course. As long as it can read either Prometheus, so pull, or it can somehow collect the StatsT packets. Maybe you're running collectD. It has actually agents for both, so we can decide which one works for you better, and that's out of scope. So we'll do. I'll work on articles on how to set things up. But for now, we're shipping an option you can turn on. I'll see what we can do. Please share your results on forums. Maybe if you struggle with reading some data, understanding what's there, we can discuss that. So quickly, quick look on what's available today in Nightly Build. This is an initializer, Rails initializer, and I'll basically describe our API in later today. So we have we have HTTP requests. This will appear as FM underscore and HTTP requests. And it's a simple counter, total requests made. But here, because we are in Rails, we are able to understand the context. We also can understand which control and which action is being, actually requested or, processed. So here, these directly maps to Prometheus labels. So each control and action creates a metric with a label. So controller might be host controller, action might be show or index, and so this way you can easily count a number of requests per individual control and action. We have total DB and view duration. Again, for this is per individual control and action. Of course, you can aggregate the data and see overall total duration if you want. The request counter was just a counter, and this is histogram. Histograms are used to measure basically durations, and I'll talk about this later. So these are in milliseconds, so you can tell how much time was spent in total during TB and view. These three guys are the ones that are reported in the production log or development log. If you do request at the end of a response, there are this timing information. So this is actually published by Rails using its internal notifications API. So we just hooked and published this into our telemetry API. The very same situation is for Activerecord underscore instances. That's a number of instances Activerecord model. Or, every time you create a class you load a class from database or you create a new module, there is a counter there that's increased by, of course, number of modules you instantiated. And this is per class, so you can tell if you see, maybe memory usage is increasing. You can tell which particular class, maybe that's subnet or discovered host, is actually being allocated more than others. And we'll see this on a demo. And then we have logins, so number of successful, failed logins. It can be useful when someone's trying to brute force you. And we also have a brute force locked login. So every time I think you have 10 attempts to log in if you're using the username and password authentication. And if there's a brute force locked, which is, I think, by default 5 minutes, we increase this counter. And then we have proxy duration. So every time we call a backend using the proxy API, we have a proxy API stack in Core that is basically used to access all the proxy features, all the proxy endpoints. We are measuring the telemetry measures, the time spent there, again in milliseconds. And because we don't have actually it's Sinatra based, there's nothing like control or action. There's a label that you can filter per HTTP method. So this would be get, post, or delete. And also we gather proxy response codes, so 204 or 404. So as you can see, we have a couple, like a dozen of metrics there. And my goal with this initial patch was not to cover everything, because I can imagine then that we can create a lot more. We have a much more interesting data in Foreman, and also we have a lot of plugins. SSH remote execution might publish information about how much calls are stacked in queue, how much are being processed. This will be a gauge telemetry metrics and stuff like that. So as you will see, it's very easy to add your own telemetry. Now a little bit about durations, because we have 3 types of measurements: counter, engage. These are pretty much no rocket science. It's just a counter that increase or decrease, but it's monotony. So you should be only decreasing or only increasing. And then we have gauge, which is just a temperature for example, of a CPU or something, just a number, right? You read it, you sample it once a minute, once a second, that's it. Duration, though, is a little bit more interesting because let's take a look. If you go to /metrics using Prometheus, either connecting directly to Foreman, or if you are using the StatsT Exporter, calling the StatsT Exporter endpoint, you'll see this. This is actually how Prometheus exports data. It's based, I think it was based on JSON, the very first version. Now they switched to plain text, which is much more, I think, faster. You don't need to parse that using, JSON library. This is an example of how HTTP request total duration looks like. It's again, counter engage. That's another story that's very easy. But this is actually duration, time spent. By default, we measure in milliseconds. And of course, what you can do, the naive approach would be to basically measure amount of observations and total number, so sum of all of the measured values. And that's what actually histogram does. If you total duration is basically a histogram type, and a histogram this is Prometheus. So in Prometheus world, it creates 3 I would say sub metrics, underscore sum, underscore count. So this is we can see there's been 10 occurrences of this measurement, and the total number is 62 seconds in total. These are milliseconds, so 62 seconds. This gives you average, right? You can divide by 10 and you have an average of 6 seconds. That's the average number of this control and action, which is pretty bad. It's not the best performance in the world, but average can lie to you, and it can lie a lot. So what you want to do is you want to use percentiles. Percentiles are, I won't go deep into math, but what you can do with percentiles, like 99th or 90th percentile, is that you can filter out samples or observations which are out of bounds, out of control. Maybe you were restarting a server and just few of 3-4 requests were 60 seconds or something, but the others are very, very fast. So then average number is 6 seconds, but maybe it's the true story is really, really different. And histogram can help you with that. And basically how it works is, and this is common for across all the monitoring systems, it's implemented in every other monitoring systems, I believe. You divide the whole number into the whole space into buckets. So here we have buckets up to 10 milliseconds, up to 50, 200, 1,000, and 15,000, and infinity is the last one. And what histogram does, if you want to calculate percentiles, you need to store all the measurements, and all the milliseconds observations in an array or something. That's too much because you have a lot of these measurements, one control, one action, but we have maybe hundreds of observations with different controls and actions, and so you'd end up with more memory. You actually want to bring the memory consumption down, so you don't want to do that. Prometheus does support that using some, to some degree using summaries, but histograms are basically can provide you a very similar experience, but as you can see, we store just half a dozen of numbers per each individual metrics, and we can say a lot. So the way it works, let me just give this, make this short, is that the number of observations goes into the buckets. So as we can see, and let me just quickly change to the other slide. We can calculate the average, so that's 6 seconds, and we can also tell that there was zero requests that were faster than 10 or 50 milliseconds. There were actually 9 observations, 9 requests that were handled until up to 200 milliseconds, and there was only one. There was only one response that was longer than actually 15 seconds. That's infinity. So although the average is 6 seconds, if you do quantile of 50, it's actually median. That's something about approximately, and this is, you can calculate this with histogram. Histogram doesn't give you exactly the correct median. It gives you approximation. There's a function, for example, in Prometheus, it's called histogram quantile, and you give it a frame of 5 minutes. It will give you some approximation. Actually, I lied to you. This is 10 observation, not from real world scenario. I made that up. The median is exactly 200 milliseconds because the sequence is 9 observation of 200 and 1 minute response. So that's how summaries. That's how histograms can help you. It can help you understand at least how many of the responses or duration observations were out of bound, out of control. Maybe a server was restarting. Also, this is very useful if you're doing SLAs and you can set up a quantile of 99%, stuff like that. But that's not really important for telemetry data. SLAs are more important when you're doing a measurement of overall application performance. That's just a little bit on histograms, because you will need this, because if you create if you want to measure duration on anything of anything in Foreman, you create a new metric type. You will be surprised that there is no duration type. We have a histogram for that. So now a little bit of how to create your own metrics for your plugins for Core. We have an API. It's super simple. There are 3 functions basically: counter, gauge, and duration. Counter, obviously, bytes read, request processed, model instance is created. That's just a counter. Usually, counter is a increasing number, and it will go up to millions and billions. I don't know, a very high number. It's usually 64 numbers. It's 64 floats by default in most monitoring applications. What you want to show usually on a graph is rate, request per second, request per minute. So, and there's usually monitoring system, every good monitoring system will convert this to rate. So you're usually interested in the rates. Gauge is just an observation of some value of kind like CPU temperature or number of tasks enqueued. And duration that's the one that we described. It's time spent in database or request. That's histogram. So if you want to use Telemetry API, that's currently nightly. All you need to do is you can include the Foreman Telemetry helper, which provides you the 3 methods. Or you can, of course, use the full namespace if you don't want to include that. And you just basically, if you want to increment a counter, you increment a counter. You give it every single metric has a name. It's a symbol. It must be unique, of course. And if you want to set a gauge to some particular number, it's arbitrary float, so you can use any float value. And again, if you want to observe timing or duration, you use telemetry _observe _ histogram, and again a number, usually in milliseconds. It's just a float. So depending on what you write on into description field, you can say in browsers, you can say it's in seconds, so you can measure in seconds as well. There is this concept of labels or tags. Every measurement can have an arbitrary amount of labels. That was a thing, and you specified right there in the function as a. If you don't provide it, there's no tag. You can also increment by arbitrary number or even -1 if you want to decrease counter. But you can provide an arbitrary amount of labels. And this is how you add a new counter. This is the file I showed you here. This is config initializer telemetry metrics. If you go there, and every time you add a new every time you add a new metric, you want to go here. If it's in core, or if it's in plugin, you create a new initializer. You grab this instance, it's just a singleton, and you call add counter histogram or gauge. You give it a name. Again, it's a symbol, descriptive description, and then there is a optional array of tags you want to use. This is useful because Prometheus allows you to do arbitrary amount of tags. These are called labels. So we can say control, action, HTTP method, whatever you want. Doesn't matter. It's free form. But on the other hand, PCP doesn't have a concept of tags at all. There are some extensions, but in general, it doesn't. That doesn't work. So here are two examples which are more readable. And so this is how proxy API duration looks like. It has one tag called method. And now, buckets. So one more thing, if you create a histogram, you want to configure those buckets. You know, if you have let's say amount of time spent in handling a request, that's in milliseconds. You want to have some kind of a same default, and that if you add the histogram method has a fourth parameter, which is an array of buckets you want to use. If you don't provide it, it's by default it's this. It's 10 seconds, 50, 200,000, and 15 seconds. Of course, you want to maybe change that if you're not measuring time, or if that's not in milliseconds but in seconds, you want to do 0.0501. It should be exponential. The best results are with buckets which are exponentials. And you can read more about this on the internet, but this is the default. Maybe we'll change that in the future. We are just starting experimenting with that, and this is hard-coded. So if you don't provide a histogram bucket, it's default. This is how you do it. It's just fourth parameter of the add histogram method. Now a little bit more about tags, so if I create a counter that has tags, control, and action, basically what I want to do is when I'm increasing that, so here in this example, I'm increasing that by 10, I want to set control to something and action to something. Usually these are symbols or strings. In Prometheus, this will end up with fm_rails. It should be underscore here, there's no dot. And a counter, of course, that's the metric name. And then, of course, labels are directly mapped to those. So it's from to a label. It's a key value, so it goes directly to Prometheus. But if you're using StatsT endpoint, this will actually be mapped to, because StatsT doesn't have anything like labels or tags. It's actually a tree structure. That's a old-fashioned way of naming metrics. fm_rails counter .host.show, and that's what you define here. That's why you actually want to define control and action. If you swap these, action and control, it would be swapped the fm_rails counter show.host. So order matters here, and it's only used when you're sending out the StatsT packets. And some other monitoring systems, like for example PCP and several others, are using what's called instances. Basically, it's ability to have one label that is not named. It has no name. It's just a label, but you can only have one. So here, this is an example of how a counter metric would end up in a PCP using a Prometheus PMDA that would map it to something. It concatenates all the labels using an underscore. Basically, that's how it works. So if you add a new send a new label to a counter or to a monitoring metric, and it's not defined here in this definition, it will end up in Prometheus just like that, and we don't filter that out. But you won't see it in the StatsT. So that's the reason why you need to define those. Okay, so this is basically how you add your own metrics. It might seem a little bit complicated, as histograms are histograms and labels, but as we look on this slide here, it's just the 3 methods there, and you really don't need to use labels. Maybe from the first version of your cut. If you file a PR to any plugin or core, just ping me and I'll review that, and I'll be happily able to provide more details of how to do the labels or stuff like that. So 45 minutes, very nice. So again, summary. Foreman Rails now, I mean the nightly Foreman Rails exports some data. If you enable that, that's turned off. It's turned off by default, of course. You won't explicitly enable that if you want that. Best integration, point today is StatsT, which works quite nice. But in the future, I would like to see a native Prometheus Ruby client. We'll see how it goes. It's very easy to add your own metrics to core and plugins, so please go ahead and maybe today, tomorrow, try it. It's really fun, and the page is small, and you immediately see some numbers. You don't need to set up a hole in monitoring. You just hit the /Prometheus /metrics. Even you don't need to set up a StatsT. If you're using WebRig, that's usually one process, so it will actually work on development setup. So you just hit /metrics, and you can see the numbers, how they are increasing, what's going on. So developing that is fun and very easy. And I'll provide example configurations in articles or documentations later. Yeah, later. That's about it. That's the last slide. So let's have a look on Prometheus. So I have a instance running here, and I'll just do a while loop and shell and doing a hammer host list just to actually see something, because idling instance is nothing really interesting. And of course, even this loop doesn't generate anything similar to a load that is, that's seen on
Lukáš, can we pause for questions?
Sure, go ahead. We have 10 minutes, so let's do questions first.
So you said you would provide articles, but if someone wants to look right now, the main source of examples is on the PR, right?
Yes, the PR basically describes what I showed you in these slides. I'll also send you already the slides, shared the slide deck, so you can attach that to the YouTube video summary or description, and that's a good source. And that's about it. But I'm really in process of writing something. Hopefully next week I'll have at least the Prometheus, how to configure Prometheus with Foreman blog post, let's say. And later then I will have something about PCP.
Great. Another question is about the plugins. You said it was easy to add to plugins. Are there already open PRs or open issues about this to some of the plugins that can be looked at as examples?
Yep, good question. If you go to Foreman Discovery, at basic telemetry is this one, 224. Oh, it's oh yeah, the issue number is 22472. And as you can see, like as I've said, extend telemetry helper, and then here we're increasing discovered host, updated host, failed discovered host, and we also have a telemetry when discovery is using its own API to reach out to discovered hosts, discovered nodes. It doesn't use the proxy API we have in Foreman Core. It has a small little Foreman Discovery Node API resource, HTTP JSON resource. So again, we are doing duration. By the way, the telemetry duration histogram accept blocks, accept block, so we can actually give it a block, and it will do, of course, the measurement with this block and publish that. Yeah, so that's the, and here we see that in the Foreman Discovery Engine, we actually in the engine you don't need to create an external initializer. Doing this here, putting those new telemetry metrics here, so they are available. So here is one of the examples you can try.
Thanks. That's it for questions right now.
Okay.
We can return to the demo.
Cool. So if you go to 9090, and if you're running a Prometheus and scraping data like this one, you end up with this user interface. Again, this is something like, I'm not Prometheus expert, but this looks like an ad hoc interface. You want to test your queries and stuff. And the usual process is, I think, and I haven't configured that myself, is to export data from Prometheus to Grafana, I think. And Grafana now have a native, the newest version have native support for, you can enter those queries there and create the graphs and maybe do things like put that into your records or archives. So this is ad hoc thing, but it works nicely if you want to see things. So let's say Activerecord instances. So I click here, or I can write here fm_rails _ Activerecord instances, and we can see here that we have counters, some counters here in a table. So let's say operating system instance was created 1,400 times here. And if I head over to graph, we can see that there is a slight increase because I've started my loop that is, again, doing hammer host list. As we can see, there are more and more Activerecord instances of we see user is one of the most created record in this scenario. Again, this is not a typical. Again, this is not very important. Not a typical workload of Foreman. Just doing a hammer list. So what we want to usually see, for instance, is a counter. We want to see rate. So there's a rate function, and again, if you go to Prometheus help documentation, you'll find more. Prometheus has this query language, and it can provide you things like here. This is a syntax. It's a weird syntax, but you can get used to it. This creates a rate of creating Activerecord instances in a 5-minute window. So if I go here, we can see that we see these are numbers. These are amount of Activerecord models created within 5 minutes. So we can see that this is increasing. That's user. And here we saw fact. So fact name was created at a rate of 1. So something. This is a nice metric to monitor if you are struggling with memory leaks, because typical memory leak in Rails is creating a lot of Activerecord instances and then throwing them out. Maybe you load a bunch of Activerecord instances, like whole table in the worst case, and then you just show 10 first records because you're doing pagination, something like that. We usually don't have those bugs anymore, but you would see that here. You would see some spikes, hopefully. So duration, let's say total duration. Total duration is sum. So total duration, again, is duration it looks like this is in seconds. It should be in milliseconds. And let me just do count, duration count. Yeah, it's a summary. I think this is in milliseconds, but not sure if that gets transferred to seconds. Anyway, if you want to do a C average, that would be sum divided by, divided by count, I think. Execute. Okay, so this is average average processing time in Rails per individual host and action. As I said, averages can lie. So this is just for example, as an example. I'd recommend to use the built-in function that would create an approximation of percentiles. Again, if you go to Prometheus.io, you'll have that in the summaries and histograms chapter. There is the first example. Second example is how to do that. It's basically average processing time. And now I think that's seconds. I think it's in seconds. I'd expect that in milliseconds, but maybe at some point I converted that to seconds. That's possible.
Hey, Lukáš, I got a question. How exactly does it affect the performance?
You mean the actually gathering the data?
Yeah, exactly.
Yeah, so good question. So I haven't measured at all, so we need to ask our community users to enable that and observe that. Without actually, it's hard to say because, you know, how do you measure if the request processing time is up in 10 milliseconds or maybe 5 milliseconds, right? If you don't have the numbers. So I don't know. The answer is, unfortunately, I don't know. We'll see. I'd say that StatsT is nice, that it's very cheap. It just sends a UDP packet. So that's shouldn't affect anything. Also, what's nice is if your StatsT aggregator goes down, UDP packets just gets lost, but nothing is really blocking or anything like that. And if you enable a native Prometheus, that's a little bit of native Ruby code, but it's really counter. It's just a counter, right? And the same for gauge. So that's super fast. Just set a memory in Ruby. Set a variable. Histogram is a little bit more complicated. You set a dozen of variables basically, and you sum one value. So I think it's fast enough. And we should all afford that, because without those numbers, we can't focus on much more in important things, like, for example, our Puppet importer code has been improved several times now, as very slow, and we'll be able to tell maybe more when we see in the numbers. So I hope that didn't answer the question at all, but. Again, you'll see a lot of more. We also have a Ruby GC allocated object. Yeah, that was not on the list because that's kind of a. I was not on the list. I'm not sure why it's not on the list. But we also, what we do is we let's say major counts. A number of major Ruby GC garbage collector counts, major and minor. So we see that we had 2 major. Maybe minor will be much more. Yeah, we have a 24 minor GC counts here for this particular host control index action. So if you see those numbers, and again, you can, this is counter, so you can convert it to rate. So if you see some spikes there, you can tell which individual controller is actually allocating a lot of objects. Or maybe running GC is, it's if you want to allocate see allocated objects, it's here. So we can see API v2 is, as you can see, is allocating more and more objects because I just started the loop. Again, if I do rate, let's say per 1 minute, you get that number. And we could go through the all the metrics here. FM rails are the ones are the telemetry data. These are those which are exported by Rails. Then you have a couple of Go underscore because that's the internals of Prometheus usually. It's written in Go. So these are some Go in the things from the node exporter. The CPU, for example, is for starting with the node, and then we have StatsT. We should have the passenger here, passenger app count, for example. Number of worker threads should be as easy as not a number. Passenger app count max processes, is that max processes is 2. That's maybe a total number of processes, and there should be some memory, maybe proc memory. Yeah, this is interesting. Memory for individual passenger. This is in megabytes, so 400 megabytes. 2 instances are running on my system. So this is pretty much it. You can do a lot more with Prometheus. You can do a lot more with other monitoring things like PCP or collect. It's not our it's not our goal to go through that. Go and grab documentation. But we went through the basic telemetry statistics that are being exported, and I'm really hesitating. I'm looking forward to feedback. So please go to our community repos, community forum, and if you're interested, enable that. I will give you support how to if something's broken. I'll make sure it works. Go ahead and install our nightly. And try that. Or telemetry patch is pretty small, and it can be easily applied or backported to a stable version, because it basically, if I go here, it adds a lot of files, but it only modifies few files really. So it should be backportable to stable version. So maybe you want to grab that, backport that. In that case, just install FM. If you're on the SCL, go SCL enable TFM and gem install the 2 dependencies which are here, and Prometheus client and StatsT instrument, and start that. And I'm really looking forward to some feedback, and we'll see what we can do next.
Thank you, Lukáš. We've actually run out of time, so we can't take any more questions right now. If there are still more questions, please reach out to us on IRC, the foreman, in the YouTube comments, on Twitter, or on our Discourse channel. Thanks, Lukáš, for this great deep dive. And thank you, everyone, for watching.